Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Now in my channel I deal with different aspects of mathematics, physics, chemistry and biology, and today I'm going to look at the concept under graphs, and this basically is the graphs of trigonometric functions. Now in our introductory part I had said that we're going to consider basically the graphs of two basic trigonometric functions, and that is the sine of a function or the cosine of a functions. And we had said that basically these particular graphs are going to form what we call a repetitive nature, and therefore we described them to be periodic. So in this particular case, I'm going to look at a general graph of a sine of a function, and of course we're going to vary the extent along the y-axis and try to see what is the behavior of that particular graphs. So generally we have described the graph of the function, the sine of x, given as a graph that is going to start from this particular point that we described at the origin, and then we're going to see it move along that particular direction. And we had said that we're going to have the concept of an amplitude described in this particular case. I can be able to give it as a function or the absolute value of the difference between the maximum and the minimum along the y-coordinates from this equilibrium position. So therefore we can be able to describe a or amplitude in terms of an absolute value, which can either be a positive or a negative. But for the absolute value, we're going to have it given as an amplitude such. So therefore, in our description of various graphs, we're going to use this absolute value for amplitude, and that is going to represent the maximum displacement from the equilibrium position for this particular function. So I've used this one, this graph of the sine of a function x. And of course, as we said, as the graph or the function moves along this particular direction with increasing values of x, we're going to see it having a repetitive nature that we described as a period. So therefore, we had said that for both the cosine and the sine of a function, they're going to have their period given as 2 pi. And of course, that is going to imply the extent to which the graph moves along the x-axis before it starts displaying its repetitive nature. So in this case, then therefore, if you try to have another graph of a function y is equivalent to the sine over x, this is going to have an implication of increasing the amplitude of this graph by 2 units. And of course, this is going to be displayed in this particular form. So therefore, it's not going to affect the period of this specific graph, but it's going to have an extent that's going to follow along this path. And of course, this we can be able to describe it as the graph of a function y is equals to x, to the sine over x given as such. So as we go by, we're going to see that we can be able to describe various graphs in terms of translations, either in the y direction as I've shown, or in the x direction, as we're going to see later. And this is going to have an implication on the general description of a graph that we're going to have for the sine of theta. So therefore, the graph of the sine, the y to the sine of x implies that there is a translation or an increment along the y-axis for the amplitude with a factor of 2 given as such. So this particular factor is going to be referred to as an amplitude, and we're going to give it as an absolute value from our first description. Of course, this is going to follow other specific laws that we have already, or other particular aspects that we have described, especially concerning the concept of a period, which are going to be regular intervals moving along the particular x-axis in terms of pi radians, which we given in terms of this. So catch us in our next video as we're going to look at other forms of graphs, which of course are going to assist us complement on this particular aspect of amplitude. And in those specific, of course, the discussions, we're going to look at the concept of perhaps frequency and other factors that we have discussed, especially under the anatomy of a wave. So that is it for now, guys. Bye, God bless you. Catch us in our next video.